see the important trick. My suggestion: cut paste all the 6 marker questions or 4 marker questions from your paper number 2, which has come from 2016 to 2024, right? Whatever 24 you won't be getting access to. I'll be sending a 2024 paper to you. You can solve it there, right? I'll putting in the group. Just thank you. Okay. Yeah. Yeah, but exactly what? Good. A student has written that impact the environment. But what exactly, right? What exactly are the impacts we have to know, right? No, we have to see that when we see the life cycle assessment, right? Life cycle assessment will be assessing what? Life cycle assessment will be assessing that what are the impacts of any processes, right? Yes, good, very good. One student is messaging me that something with impact the environment. Very good. See, now what is a life cycle assessment? Life cycle assessment will be looking at every stage of the product life cycle, right from the birth to the death, right, of that product, right? Hmm. Right from sourcing the raw materials to make that product, and when you are disposing of, how it is harming the environment. So this is very important. How it is harming the environment. So these processes which are involved in the life cycle assessment. We do it in every step. Now, you have to remember one thing, that we have to take into process that are electricity being used to make that process. How much electricity has been used? Second, is any obnoxious gases coming out? Sulfur dioxide and nitrogen dioxide, these are acid rain, right? These are pollutants, right? Carbon dioxide is not a pollutant, right? So this is a pollutant, right? So are any harmful gases coming out? That sulfur dioxide, nitrogen oxide, or HCl, or carbon monoxide example, are any harmful gases coming out of each and every step? Finally, we have to note down the very important part, that how long can we use the product, right? Now note down this: longer we are using the product, we'll be making sure that we are making less amount of the product. Is it clear to you? This also is very important part we have to note down in the LCA, that how long are we using this product? Is it short span of time the product lasts, or if a longer is can be used, it's a good for LCA. Now in the LCA, we are doing what? We are trying to extract, we are trying to look into the part of the product. When we are making it, we need raw materials, right? The raw materials which is sourcing, we are getting source, is it damaging the environment, right? That's also thing we have to do. In the manufacturing process, we have to analyze that what are the damages done to the environment, harmful gases coming out, electricity, waste. Also, I forgot to tell, waste. If any step involve waste, lot of waste, that has to be dumped, right? So see, all the things you have to do. Now suppose I'm trying to make a car, right? I'm to make a car, right? There's a car industry, right? The car industry needs iron, right? So iron, sourcing of the raw material. See, iron has to be dug from the ores, right? And that causes huge amount of pollution. Mining causes huge amount of water pollution and air pollution. Remember this thing, right? And lot of energy is also used, right? Pollution, electricity, waste products are given out or not, harmful gases are given out or not, and how long the product can be used. Second, third, when you're disposing the product, is it harmful to the environment, or is it needing huge amount of energy to dispose it? So suppose you're making a car, the car needs iron. So iron ore we have to dug in, so that causes pollution, right? Now after this, what happens due to the manufacturing of the car, right? In the manufacturing of car, are there any harmful fumes which is coming up? Harmful fumes such as carbon monoxide, hydrogen chloride, or sulfur dioxide, nitrogen dioxide coming out. Now during the manufacturing, is a heavy amount of waste generated. Waste has to be disposed to the environment, right? So second step is manufacturing, packaging, right? Are any harmful chemicals being used to extract that process? Third process is while using the product, right? While using the product, see, a car uses fossil fuels, isn't it? So it releases some greenhouse gases, isn't it? Example, while using the product, is it damaging the environment, or any harmful gases coming up? Most important, using the product, I'll be flagging in red. how long the product can be used. This is a very important part. We miss it. How long? This will be getting a plus point from the LCA gradation. Pluses. You get pluses of the LCA. If it is longer, you use the product, it will be better for the LCA. Finally, disposal. Product after the cycle has to be disposed. When you're disposing it to the landfill sites, is it polluting the land and water? Do we need huge amount of energy to transport it, right? Suppose a big car, suppose a car, the cars has to be transported, right? That also uses fossil fuels, releases pollutant to the environment. Now, there are some products which is disposed that has to be burnt, such as plastic bag. The plastic bag has to be disposed of and burnt. That is called as incinerated. You can note down this. So this is all about the life cycle assessment you are doing, right? There's a case study which is there. What's the case study which you're having over here? In the case study, we are having what? We are having the example of a plastic bag and a paper bag. In these two case studies, we are seeing that how does a plastic bag affect? See, we have to give plus points or minus points and add up those pluses. See, I told you what? There are 4 steps. Sourcing the raw materials. When you're sourcing the raw material for the plastic bag comes with polymerization, right? We are taking from cracking of crude oil, right? So we are using crude oil, right? Now, paper bag is obtained from what? Timber, right? Is it clear? Now, during the manufacturing process, this is crucial. This plastic bag is usually a alkene. Alkene is obtained from fractional distillation and cracking. This uses very less amount of energy. See, plus is a plus coming up. Waste is also very minimal. Another plus. Is it clear? Is it clear to you? Energy or electricity needed during the preparation of that plastic, the ethene, right? Is very minimal. And very minimal amount of waste is also generated. So pluses we are getting in the manufacturing process of plastic bag. On the other hand, the paper bag, what we do? We have to take timber, means that trees. And after that, what we do? We have to break it into small pieces. See, energy. And after that, we have to crush it into powder. See, huge amount of energy, right? And finally, lots of waste is generated. So energy, how much is energy and waste? So lots of waste is there. So it's a minus over here. So it's a plus over here. Now, using the product, right? While using the product, plastic bag can be used for a longer time. So another plus over here. See, isn't it? See, it's an irony, right? Paper bag is better for the environment. We know that than the plastic bag. But as for LCA, it is not. See how we are telling it. Paper bag can be used once. So negative. See, you're putting a negative. Finally, when you're disposing the product, now this is a very important part. Plastic bag is not biodegradable, right? Not biodegradable. It will be taking up space in the landfill sites. Understood? Understood? So negative. Whereas paper bag is biodegradable and it is non-toxic. So it is a plus. Is it clear? So over here, can you see this? Here it's a plus coming up. Here it's a minus coming up. Here's a plus coming up. While using the product, it can be used for a longer time. Here's a negative. Only product disposable is a negative and here's positive. So over here, can you see this? We are getting 2 pluses over here and one plus over here. So as per life cycle assessment, what we think? That plastic bags are better, right? Because it takes less amount of energy while manufacturing it, less amount of waste is obtained, and it can be used for a longer time. But on the other hand, paper bag will be using lot of energy to process the timber, right? Lot of waste will be there. It can be used once, but only positive part of life cycle assessment of a paper bag is that it is biodegradable and non-toxic, right? So this is a thing we have to know. While you are calculating the life cycle assessment, is always energy, always important that you have to consider the electricity or the energy are using. What are the pollutants it is giving out? Is it harder to dispose of? Finally, most important as per me is how long you are using the product. Longer, better for the LCA. Finally, the product disposal, that also how much energy and how much toxic waste is coming up. So these all come under life cycle assessment. Good? Is it clear? My suggestion, do study the reuse. Just Jan, just to message me. Reuse. Already I've told you, right, that this part 14.6 from CGP. Hi, go from the CGP to do it. I'm coming to the part of the portion. I'm just